Introduction of the touch sensor. Touch sensor is a device similar to a switch, which is equivalent to the robot's skin senses, used to detect the state of collision with objects. It is commonly used in startup switch, collision detection, remote control, and other scenarios. The raised part like a little red cap is the button of the touch sensor, which serves as a buffer and reduces the blind spot of contact. Principle of operation. When the red button of the touch sensor is pressed, the two metal pieces inside contact and form a closed-loop circuit to generate electrical current. Conversely, when it is not pressed, the circuit is broken and no current is generated. The controller is based on this change to determine the state of the touch sensor. Hardware testing. The touch sensor can be connected to any P port of the controller. Here we choose P1 port. After the connection is completed, click the touch icon in the built-in test interface of the controller to enter the touch sensor test. The area here shows the current status of the sensor. When the touch sensor button is pressed, it will show the collision status value 1, while the marker box will turn brown, and vice versa without color display. In this interface, you can also click on these two icons below to turn the alert sound on or off. Programming. In the ZM Robo 3.0 programming software, the touch sensor command is a judgment-based module that returns a judgment value based on the different states of the sensor. For example, here is a program that applies the touch sensor module. Please note the running status of this program. This is a program to get the return value of the touch sensor. Please pay attention to the running status of this program. The return value can be 1 or 0. When it is 1, it means the judgment condition is valid, that is, the touch button is pressed. When it is 0, it means the condition is not valid, that is, the touch button is not pressed. Frequently asked questions. Sometimes we want to implement the function of executing the program only once for every touch of the sensor, but the actual result is often not satisfactory. Here we take a program that makes the buzzer sound as an example to explain how this happens. The controller is running very fast. When we press the touch sensor, the buzzer sounds and goes to the next cycle at the moment of completion. At this point, if the touch sensor has not been released, the controller will again determine that the condition is established and sound the buzzer again, just like this. Here are two solutions to deal with this situation. The first solution is to increase the waiting time and provide interval time. This is the simplest and most brutal solution, but it is not ideal. If the press time exceeds the waiting time, there will still be a touch multiple execution. Moreover, we can't detect changes in the state of the touch sensor during the waiting process. The second solution is to apply the judgment-based blocking module. We can divide states of the touch sensor into two parts, established when pressed and not established when released. This way, when the button is pressed, the execution program will wait for the button to be released before entering the next cycle. This is the introduction of the touch sensor. Thanks for watching.